Okay, can you guys hear me? Okay, if you can type yes.
Yes.
Okay, great, great, I see that. Let me share my screen with you guys. Okay, all right, good afternoon, everyone. Welcome to the seminar. So today we're gonna talk about the power and energy. So this is a hot topic. I checked the website. I searched for most important innovations in electrical engineering in 2022. And guess what? The top 30, majority of them are about power and energy. Okay, so this is a very important topic. So today, what we're gonna cover, about myself. Well, let me read it. Yeah, my name is Yu Meng. So I got a PhD in computer science and MS in electrical engineering. I'm currently a IEEE senior member. I'm a co-founder of Association of Young Scientists and Innovators. So yeah, I'm a passionate coach that coach middle and high school students to innovate in STEM. So my students participate in pretty much many prestige competitions, okay, including ISEF, if you know that, that's International Science and Engineering Fair, STS, Science Talent Search, that's a competition as well. And also ACM Cutler Bell Prize. This is a high school version of Turing Award. If you know Turing Award, that's ACM Award. So this has the same format, but the winner is winners are high school students. So let's say the future technologist, and also Davidson Fellowship, Coca-Cola Scholarship, Hack MIT, and MIT Hackathon. I mentioned this because I really recommend these competitions to you if you want to do innovation, if you are interested in STEM, and you want to start your research. And also, I'm a certified master trainer of MIT App Inventor program, and also I'm a recipient of Teacher Excellence Award of the App Inventor Foundation in 2022. That's about myself. All right, so we're going to cover a couple of things. So first thing, what is the power grid? How power grid works, which means we have a power system. So how this system works? Let's take a look at the big picture, and then we can drill down to individual topics, right? So we're not going to cover every topic. Aside of power system, we're probably going to touch a little bit about renewable energy. Right? That's the hot topic we're talking about as a buzzwords, right? And also microgrid. And also a very interesting topic is the United Nations have a SDG. If you heard about SDG, they have 17 SDGs, Sustainable Development Goals for the United Nations. On the SDG 7, number 7, it is about power and energy. I think the topic, we're going to check out the topic. I think the topic is clean energy. All right, so yeah, let's dive into it. Anytime if you have question, you are welcome to post your question to the chat so that I can respond. I can respond promptly, let's say. All right. So if you look at this is a very simple diagram, but you probably this gives you a overall picture of the power system. In our power system, the first part is the generation, right? So we're going to generate power. What can generate powers? So nuclear, that's right. Natural gas, that's right. Coal, coal. That's right. So these are three traditional power generation energy sources. Okay. In recent years, we emphasize this renewable and the wind. Okay. So look at here. If you see this turbo rotor, right? A rotator right over here. That's the wind energy. That's the wind generator, wind energy generator. And also you see some other sign. We're going to talk about. We're going to talk the 7 renewable energy sources a little while later. But just let you know, a big picture is that we add a new type of. Well, actually, it's a new. It's not a type. It's a type, but there is a several resources under renewable energy. So it's like a PV, right? Power voltage. It's a solar system, solar energy, and also wind energy. We have other renewable energies as well. So all these are resources. We're gonna generate some power for people to use. Okay, after generation is done, what we're gonna do? We're gonna do transmission, which means we're gonna deliver, because the generator is not necessarily in the same place of the consumer, right? So we're gonna deliver the power to the consumer. Okay, so now the first thing is for the long distance delivery, we need what we call it the transmission systems. Okay, what is a transmission system? You're probably gonna see like a very in some places, especially out of city, not in the city, but maybe in the highway between cities, you're gonna see this like a big tower, right? This big tower is actually the tower to deliver power, powers. It is very tall. The reason is the voltage is very high. Why we need the high voltage? I'm gonna explain that to you why. Okay, so let's see. Let's say the generation gonna deliver to nearby cities. What we're gonna do? We're gonna step down the voltages, which means convert the voltage from high to low. The reason is high voltage is very dangerous to humans, right? However, the high voltage is good for what? It's good for deliver electricity. Okay, so that is why whenever the power goes to near city, we're gonna step down the voltage, and then, well, guess what? The transmission tower, it carries up to 345 kilovolts. Okay, that's a very high voltage. And in the city, I mean, just right out of your house, it stepped down to 120 volts to 240 volts, which is fairly low, but it's still dangerous to people. Okay, so the direct current, if it has like a 32 volts, we consider it's harmful to people. So to be careful to avoid high voltage shock. Right? Okay, so yeah, this is a big picture of the system. We're gonna look at a little bit detail on this. What is energy? Energy is the ability to create a change, for example, creating motion. So you're gonna do something. Essentially, we're gonna do some like tasks, right? The tasks, if we wanna do some work, do some tasks, we need energy to do it. Okay, we're gonna consume energy to do it. The tasks like lifting a box require an amount of energy to complete. So what kind of energy sources we can use? Well, a lot of people use the batteries, right? The battery can hold a particular amount of chemical energy, which is this kind of energy is a chemical energy to drive a circuit, of course. Okay, so to drive a circuit, it requires some energy, right? It comes from a battery. So you guys know that. Right. All right. Okay, so yeah, human beings, we need food to live and work. So that means food is a kind of energy, right? And the cars need fuel before driving. We're gonna fill the gas, otherwise you're gonna charge it for new kinds of like electric vehicles, right? Okay, so yeah, the energy is something that we require. Okay, have you seen a lot of like sci-fi movies, right? So have you observed one thing? A lot of these movies are about energy bars. If you have energy, we can do a lot of things. We have the control over the world. So that's the basic idea. So energy is the most important thing. Yeah, I had a friend. I used to, when I remember one thing. When I was at school, I had a friend. He's a Korean. He likes to drink. Yeah, he liked to drink. And he told me, if we can drink, okay, so if we can drink together and watch the same opera, and we have energy, so we're in the same world. That means, so how important the energy is. And also remember this. This is something for the I think this is one of the most important things in the national strategy. Okay, so yeah, what is the power? The power, well, it's essentially, we say energy, right? And a lot of times we talk about power. The power is, let's see this. Electrical power is the rate at which electrical energy is transferred by an electric circuit. Okay, so basically, let's forget about this. Let's say this way. This is the power means in unit time, in certain amount of time, how much power the system can generate. So the more the better, right? We want it very powerful. That means in the same amount of time, this system generate more energy than others. Okay, that means the system is more powerful. So yeah, well, essentially for some mathematics, I'm gonna leave it over here. So we need this a little bit. Just remember one thing: the power, right? The power is what is the W is the energy created, right? Divided by T. T means time. Okay, and also there is some equivalent mathematics, especially for this one. Okay, the V and I. P is equal to V times I. V is voltage, I is a current, right? So why I want to say this, because we're gonna do a little bit of math, a little bit, not much, a little bit of math to see why we need something. It's called a transmission. Okay, transmission system. Okay, we just mentioned, right? We have generation, we have transmission, and the third part is distribution, right? Distribution. So we have generation, and then we deliver the power between the generator and the cities using in transmission lines, right? So why we need the transmission? So we're gonna explain it using a little bit of math, okay? And then in the city, we're gonna step down the voltage and send the electricity to the users in the cities. Okay, right. All right. So yeah, look at here. This is another picture to see how the electricity is generated from the generator and how it's delivered all the way down to the consumer, which is either in business or residential consumers, right? So look at here. So this is a power station. Wait, I think this means this is a generator. Okay, so the generator the voltage is about about 10K, about 11, yeah, it should be like 11K, 11,000 volts. Okay, so in the power transformer, we're gonna explain what is a transformer. Essentially, the transformer is a device, but this device could be very huge, right? Very huge device or equipment. This is the equipment that can convert the voltage from low to high or high to low, change the voltage. Okay, so the power generated is 11,000, but when after the power transformer, it's going up to 345. Okay, so volts. Okay, so and then it's gonna go to the B. Look at the B here. The B is transmission. So this is the transmission, okay, between the power generator and the end user. Okay, and then the power is step down. Okay, it's step down. This is another, it's called a transmission substation. This substation has another transformer to transform the power from hundreds of thousands to about like 24K, let's say, for example. It's about like a couple of dozen, a few dozen thousand, right? So that will step down. And then in the distribution substation, I don't know, it's gonna further step down. Well, just right before this, right? Okay, look at here. All these, we call it the distribution, right? All these, we call it the distribution. So now this electricity is gonna go to two types of consumers. One is business, one is residential. Usually, the business is gonna consume more than residential customers, right? So that's why the business, we need I mean, the voltage is a little bit higher. It's probably going to deliver like a 3-phase electricity. So don't worry about that detail. The bottom line is, yes, the electricity delivery to a business consumer will be more powerful than residential consumers. So yeah, this is a big picture of the power grid. Okay. So any questions so far? Okay. If not, we can continue. Anytime if you have question, feel free to type it in the chat. All right, so look at here. So we have a new type of consumer, which is EV, right? What is the EV? Electric vehicle. So going forwards, we're gonna use clean energy, and electricity is a kind of clean energy, right? Okay, so why aren't there any power lines outside your house, right? Our houses. That's true. We don't have that because all the construction, all the new construction using underground cables. So you don't see that, right? If you go some very, very old places, and it's you're gonna see in some area they're still using the poles, you know, the big pole, and you have those lines in the air. So for now, because you are in the new developed residential district, so everything is underground. Okay, so yeah, there is a new consumer, which is the EV, because the EV, did you know one thing? Well, actually the price of electricity is different from time to time. It depends on the time. In the peak time, the price is much, much higher than the low, than other, you know, other time. So, well, let's say this way. For now, we add another thing, which is the electrical vehicle. So this is one of the consumer we're going to consider in the future because we have more and more electric vehicles, right? And in the future, maybe 100% going to go to EVs, right? I estimated, probably in 10 years, I would estimate like in 10 years, the manufacturers won't produce like a fossil, like for gasoline vehicle, right? And in 20 years, we won't see any like this old type of vehicle. I mean, consuming gasolines. Yeah, everything. I mean, all vehicles will be, EVs. Okay, so all right. For now, let me see. Yeah. So let's take a look at the power generation. So how a power can be generated? What is the major parts, right? Let's take a look at this one. This is actually nuclear. This is a nuclear power station. So this is the principle. This is a diagram to show how nuclear power is generated. Look at here. So essentially, this is a big construction. Okay, very solid construction that prevent exploration. Right? So this is what you see that in the there is a very solid white building outside the nuclear power station. So with inside, there is a nuclear reactor vessel. It's right over here. And we have the control rods right over here. So no matter what, so this will generate a lot of heats. This will generate a lot of heats. So how this gonna work? That's a nuclear reaction stuff, right? Let's assume there is a nuclear reactor. They produce a lot of heats. And this gonna heat, what is this? This is a boiler, which is, water. It's gonna convert the water to steam, very, very hot steam, okay? So this steam gonna drive this turbine. A turbine is a device to convert heat to mechanical energy, right? Heat is a form of energy. It can be converted into another form of energy. What is the other form? For here, this is gonna convert heat to mechanical. Okay, so this gonna rotate. This turbine gonna rotate, and this rotate will drive the generator. Okay, the generator gonna consume this mechanical energy and generate electricity. Right, this electricity gonna go out, gonna be sent out. All right. So again, if you look at here, there is a condenser. This is a condenser, which means it's gonna. This will be what? This will be converted the steam, the steam, water steam to water, to liquid water. Okay, so it's a condenser, and this is a cooling part. This is a cooling part. Where this will go? A lot of times outside the power generation plant, you're gonna see a lake with a lot of water. So essentially this needs a lot of water to what? To do the cooling down, the cooling process. Okay, so yeah, in this diagram, essentially you're gonna see how a generation can be performed, right? Well, of course, in this case, this is the nuclear station, but for other form, like a natural gas and coal, right? The coal generator, it works. Well, essentially, the principle is the same on the right-hand side. All these on the right-hand side is the same, but the left-hand side will be much easier for coal and natural gas, right? Well, essentially, you're gonna burn it and let it burn, right? So yeah. So look at here. This is a coal generator. Okay, I put it over here. So essentially, it still needs a couple of things. Number one, the boiler. So this is a boiler. Yeah, this is a boiler. And it also needs a turbine, right? The turbine is right over here, convert your heat, drive the heat. I think it's, yeah, right over here. Yeah, it convert the heat and drive to the, use the heat, steam heat, to drive the turbine, so that it converted into mechanical energy, right? And then there is a generator over here. This one is a transformer, well, essentially. So this is the way to generate the core. This is a coal generator, right? What's difference is, instead of a reaction vessel, this needs a deliver. There is a machine that deliver the coal all the way up to the boiler, right? I think that's for combustion. Right. Okay, so yeah, in the United States, we don't use a lot of coal, except for one state. You know which state? In Texas. Yeah, you can imagine that. In China, 2/3 of the energy were coal energy. 10 years ago. I'm not sure the recent data. I know China used a lot of renewable energy. They did a very good job. But in the United States, anyway, we don't use a lot of coal energy. But except for Texas, Texas used to generate 40% of its power using coal. But now I think the government won't allow, put a restriction. They can maintain the coal generator, but they don't build new coal generator, which means whenever those old coal generator retire, there won't be any new coal generators. Okay, transmission. So this is a little bit interesting thing. If we look at this one, as I just mentioned, this is there is a part, we call it the transmission. The transmission essentially gonna deliver the power in a long distance. Usually it could be like 100 miles to hundreds of miles, even over 1,000 miles, right? So when you deliver your power, there is one challenge is, as you know, this is in the circuit, there is what? Energy loss, power loss. Why power loss? Because the heat. Okay, so if you want to deliver energy through the power line, you're gonna always face a loss. The loss can be 25% of the delivery amount. So 25% will be lost in the circuit. That's a big number, right? So how can we reduce this part? That's why we need to raise the power from a low power to a high power. Okay. Yeah, let's do a little bit of math to derive this. Why we need that. As I just mentioned, you probably gonna remember the P is equal to VI, right? Okay. In another way, we can say the I is equal to P over V. That's the math, right? Yeah, the I is current. Okay, I is current. So what is the power loss? The power loss, we call it the power loss PL. Let's say PL. Power loss is equal to the I square R. I square R. Here, the I is the current, and R is the resistance. Is the resistance in the circuit, right? Because the resistance is a fixed number. Yeah, depends on if your power line is determined. So we know this resistance is a fixed number, is a constant number. Okay, so let's do some mathematics, right? The I square, look at here. So we substitute this as a P square, V square, and times R, right? So yeah, times R. We can write in another way, it is a P square divided by R, and then times 1 over V square. Look at here, this is a constant. Agree with me? Why? Because the power you want to send is determined by, it's not determined by the circuit. It's determined by how much you want to send. I mean, we decided, right? The R is decided by the system. As long as the line is fixed, it's determined. We know this, the R, right? We can measure the R. So this part is a constant, Do you see what happens? The loss is inversely, I mean, proportional to what? To the V square, which is the voltage square. So that means the higher the voltage, the better, the lower the power loss will be, right? Yeah, should be times R. Yeah, I think it's a times R, right? Yeah, this should be times R. You're right. Okay, so let me, yeah, thank you. That's a really good catch. Okay, so I'm very glad someone is listening. All right, so let's say power loss. Yeah, the power loss is equal to P square times R. Okay. And times, yeah, 1 over V square. So this is the formula, right? Well, even this is a constant. So that means that's why we want to step up the voltage. That is why we want to step up the voltage. Okay, so here's the question. Why don't we step up the voltage as much? I mean, how much we can raise it? Well, there is a limitation, right? It's called the insulation. Look at here. So if we have two wire, they have a gap. No matter what's in between, okay? If you give a high voltage, the insulation will be damaged, which means it's gonna become to be conductive, right? So there is some physical limitation. We can't raise it very, very high. Well, because if you can consider how much is that in the United States, the highest is 345 kilovolts. In China, they have better technologies. For long distance power delivery, they use 500 volts, and even 1,000 it's at the 1,000 kilovolts. Yes, 1,000 kilovolts, which means 1 million volts. Yeah, in delivery. So they can raise it very high because their insulation is better. Okay. All right. Okay. Other questions? Okay, yeah, can continue. All right, so let's talk about the distribution. Well, on the distribution, we probably gonna look a little deeper into it. Well, actually, when we step down, we don't step down one time, right? So in the suburb, we're probably gonna step down a little bit, and in the city area, we're gonna step further. So that means usually we use multiple steps to step down. Okay, so if you look at here, do I have a number? Okay. So, right, see here, the first step down, Well, essentially, this says 138 kilovolts or 230 kilovolts. Yes. Well, but in Texas, we use 345, right? Kilovolts, and also 138 kilovolts. We use both of them. And the other one is I never see this 230 kilovolts. In Texas, we use 169 as well. But anyway, so you're gonna see this is a high voltage. But the first step down, we step down to 26 kilovolts or 69 kilovolts. And in another step, we step down to 12 kilovolts and 4 kilovolts. See here, so these are multiple steps to step down the voltage. All right, so now at your in the consumer, so we probably gonna step further down. This consumer, I'm not sure. So you probably gonna see some green box. It's about like it's like a 3 feet high. It's like a 3 by 3 by 3, that big a box over there. If you see that box, that is the transformer. Instead of hanging on the pole, it can be a underground one. I mean, transformer usually it's above the ground, but the cable is underground. So you're gonna see a green box over there. So if you see the green box, most likely it is a transformer. So you won't see other facilities, public facilities, in the green box in that size. Okay. So let's move on. Okay, let's take a look at just one interesting thing is the transformer. So we're gonna use, I mean, in electric power system, there is a whole kinds of different transformers. The purpose of transformer is to increase or decrease the voltage. Okay, so how this can be done? If you look at here, there is a formula right over here. So essentially, this is given by when? This is given by Friday's 法拉第怎么讲？ This is by a law, right? By a physics electromagnetic law, which tells us the number of coils. I mean, the number of coils times the voltage on this side, on the primary side, is equal to the number of coils on the secondary side times the voltage of the secondary secondary side. Okay, they are equal. So they are equal. So this is the formula. Okay, so if you want to step up the voltage, what should you do? What you should do? Well, essentially, you should do, I think this is I think this is wrong, right? This is wrong. Okay, there is a typo over there as well. Voltage. Yeah, the voltage. Yeah, I think the voltage one over N1 is equal to voltage 2 over N2. I think this is the formula. Okay, so this is the formula. That means if you want to step up, you're gonna wire more on the secondary side. Okay, if you want to step down, you provide like a less wire on the secondary side. So this is basically the idea of how transformer can work. Okay. All right, so let's see some other topics. Yes, we talk about the substations. Yeah, the substations step down the voltage from the transmission lines, right? So I want to show this picture because a lot of you guys don't know what it looked like. Well, it's pretty big. It's a little yard. That's why it is not just a transformer. It is a whole lot of like, lines, power lines and devices to make that happen. So I think the key equipment, it's still the transformer, but there is some other things. When you drive around your home and some other places, you're probably gonna notice there is this kind of yard, right? This kind of yard. This is when you see that again, you know this is a substation. Well, the thing is, the function is, they, number one, step down the voltage. Number two, send out more lines to different areas, to the end user, because when you do delivery, transmission delivery, there is less lines, right? There is one line, let's say. If you go to the local city, you branch out many lines. We call it the feeders. I didn't type it over here. It's called the feeders. Usually in a substation, you're gonna see at least two feeders, two feeder lines. Well, likely it can be like a 4 to 8 feeders, and some large substations, they branch out 16 feeders. All right, so okay, so we're gonna so for now, we finished our power system. That will give you a picture that how these power is generated and how it delivered, how it's be sent to the final consumers, right? Customer consumers. So let's talk about a very interesting topic, which is the renewable energy. What is a renewable energy? What kind of types? How many types of renewable energy? Well, actually, we can say there is quite a few. Usually, these are the 7 most important renewable energies. Solar energy, well, essentially convert the sun's light into electricity, right? And the wind, that means the wind to electricity. And hydro electric, that's from the water energy into what? Water moving energy into electrical power, right? Energy. And we have other things. It's called geothermal energy, ocean energy, hydrogen energy, biomass. I want to say, I have a little video for you guys to watch. It's pretty good. But in general, every types of these, I want to say the first 2 are very popular because they have a lot of benefits, right? Over the limitations, right? Over the limitations. But the solar energy, yeah, it's been very popular. The good thing is, sun energy, solar energy is everywhere. We can receive it in a very convenient way. I think the only limitation is there is a big front cost, which means to realize that, to make that happen, we're gonna pay a lot of money before we can enjoy the benefit. So I think that's the only limitation. However, long-term, yeah, it's still worth it. I think the government and the society is proving one thing, that in long term, it's beneficial, solar energy. And the wind energy is another one that we can consume, we can use, right? It's still unlimited resource, and it generates nothing. It does not, emit dioxide, right? Well, the problem for wind energy is there is 2 things. Number one, the wind energy cannot build in the city, right? You can't use a big turbine in the sky in city. That is not that is not possible. So for all the wind energy, we have to deliver it from a long distance, I mean, from distance away. So that's the one thing. Okay, we cannot build just on our house roof. That's number one. Number two is, wind energy destroy our environment. That's very bad. You probably don't think about that. So it has been reported that the turbine damage a lot of animals, like birds or whatever. So that is a concern. That's why Texas is good, because the Western Texas, they pretty much grow nothing. Okay, so well, it won't destroy anything on the environment. So yeah, we have hydroelectricity, hydro energy, and geothermal, ocean energy. I want to say this, these three, they are limited available, but in the place that is available, it is huge. But they all have some concerns. It's really hard to widely apply, to generate any to generate powers. Take an example: the hydroelectric energy, right? It is huge. You know that this is huge, but usually we don't do that. But China is still using that. I mean, in the United States, we don't want to do that. Why? Because it is a big damage. It's destroy the environment. For example, like a fish, right? You totally change the environment, and all the fish disappeared. All the live beings disappeared. Why? Because you changed the whole thing. You change the whole environment. That's really, really bad. That's why in the United States, we don't use that a lot. Yeah. 但是中国的三峡还在搞，对不对？还有他们有很多水电站，我不知道这个应该怎么样评估。I don't know. Yeah, I don't know how to evaluate this thing. I think it's still in debate. Well, I don't wanna, we don't have a lot of time to address each of them, but there is another thing is, hydro energy. Hydro energy is really good. Why? Because if you have hydrogen, this is a technology that got a lot of attention, and this probably represents the future energy, right? So I've seen more and more research on this. The reason is, look at here. If you wanna, this is only consume what? Hydrogen, oxygen, right? It's available. It's a great source in the air, right? It does not emit any dioxide, right? And it's easy to use because you just wanna doing combustion, even though it is dangerous. Just it needs a high quality, technology to control the combustion. But this represents a great future. So you're gonna put some focus. I mean, put some attention on this one. Yeah, biomass. I don't want to. So there is all kinds of biomass, right? I think the problem is still we use the waste, right? Just large waste to generate energy, but the problem is it's going to generate what? Dioxide. It still could. I don't know. This is a big area. This is a big area. There is a lot of different kinds of biomass energy, and the application can be totally, the technology can be different, can be totally different. So if you want to focus on it, there is a lot of interesting topic in this as well. So, okay, look at this, and that is the 3 category. I want to divide these 7 categories of new technology, new renewable energy sources. If you want to get more information, I have a very good YouTube link right over here. You can watch more to get started, right? All right. So microgrid. Okay. So yeah, for now, there is a new idea that we're going to build our power system at what we call it the microgrid. The microgrid will be inserted as a part in the distribution system. Okay, if we go back to distribution, so we have somewhere in distribution, right? Yeah, this is a distribution. If you look at here, these are the distribution. So we're gonna add this part to somewhere here. Let's say this is a micro system. This is a microgrid. This is a microgrid. You can add between, I mean, within the, the power system. Okay, traditional power system. Why is that? There is a reason is, see here, this traditional power distribution system, they are all consumers. They don't generate any electricity. Okay, they only consume electricity. But look at here, if you have your solar panel on the roof, so that means your house is a generator. So you are a consumer, and you at the same time you are a consumer and a generator, which means you play two roles at the same time. In that case, we're gonna modify our existing power system by adding microgrid. Okay, so yeah. So the basic idea, there is a very smart idea right over here. Look at this. Yes, I do have a YouTube right over here, but the bottom line is, look at here, you are generating. See here, you use different generation. You still connect to the traditional power grid, including this, right? Right. Okay, so one more thing, which is very important. Look at here, these are some buildings, these are some buildings. This is what, I don't know. This is something. Oh, this is a residential house. Look at here, this is EV, right? So these are the consumers, all these are the consumers. But the generator can be, traditional power plant, okay? And some other power resources, traditional power resources, and the wind and, solar. And there is another one. What is that? What is that? Look at here, there is two things we don't see it before. One is the storage, the battery, okay, the battery. Why we need the battery? So look at here, what is the cost of the power system? That's the peak capacity. Okay, that means capacity, the peak capacity. So what is the maximum power I can deliver, right? However, the power, okay, so what the consumer needs, the consumer gonna pay what by what? By the power it consumed, the amount. So here is the thing. If we can store the power in the peak time, no, in the low peak time, it's not a peak, value time, let's say the value time. We save that energy and use it in the peak time for ourselves. If we have such a battery, so we're gonna pay less. And it's gonna reduce the pressure on the power system. That would be great, right? So a microsystem gonna add this storage, Okay, so, and also it may add a, backup gas generator, which means this is just a tank, you just buy a tank of gas. Just in case you short of power, you can add on. So this microgrid gonna reduce the demand to the traditional power system and also increase its own sustainability. Right. So yeah, these are some very interesting topics, and there is every corner could be a very interesting topic you can dive in. So yeah, I want to say lastly, I want to present this thing. Look at here for your hackathon project. You have a lot of things you can do, right? trying to find some idea in the United Nations. It's not United Nations, right? Sustainable Development Goals, number 7. If you look at the number 7, you click on here, you're gonna see a page. Okay, so this link to the United Nations. This is for the SDG 7. It's affordable and clean energy. So you're gonna find a whole lot of things. There is some facts, some goal targets, and you got some like additional resources. Okay, so find your ideas. Well, number 1, when you want to design something, you're gonna do some survey. Okay, if you want to find the idea, the first thing is not find the idea, is to read. Okay, to understand what happens, you know, and what is the future. Okay, think about what is the future and find your topic. Find an inspiration. So what gonna move you? Okay, what moves you? You can pick that kind of inspiration, you know, for your topic to research, right? Look at this page. I leave this link over there. You're gonna find this one is very is useful. Okay. All right. So if you want more information, you can go to the department. This is the link to the Department of Energy, right? The energy.gov. If you look at here, look at what are the most prominent topic. Number 1, clean energy. We talk about it, right? Solar, wind, water, you know, geothermal, biomass, and other, you know, and other things. Yeah. The second thing, yeah, the nuclear is pretty clean. It's still clean. However, the nuclear is the safety issue. It is really, really hard to, you know, to ensure the safety for nuclear power station. So we still, after 40 years, where after 40 years, maybe 50 years, more than 40 years, we're still not able to control the nuclear power station perfect. So we still see that strategy, right? In Russia, in Japan. So which needs more efforts. Okay. The second thing is the electric power system. We spend a lot of time explaining electrical power system because we don't know. Probably our high school students don't know much about this. So yeah, I'd rather spend a little bit more time on that. Energy storage. The reason is we're gonna cut the peak demand. Okay, we want to cut the peak demand. We want to store the energy we want into the storage, and we can use it in the peak time rather than we increase the pressure on the power system at the peak time, right? That is a very important topic, you know, to do, right? Obviously, hydrogen and fuel cell. I think this is the most. There is a lot of like a specific technology. If you want to dive in, take a look at that. I have seen some high school students look at the hydrogen cell stuff. I'm not an expert on this part, but I know there is a lot of research. Okay, the fossil, well, usually the fossil means the coal, oil, and the natural gas. So it's more traditional. So just find something, you know, maybe there is some like a good topics in this area. But anyway, if you look at here, so these are the 5 areas we should be focused on. We can do something. So the starting point is, I don't think I can include everything in this presentation, but the purpose for me is to give you an entry point of the power and energy area. So that's conclude my presentation. Yeah. Any questions? All right. So yeah, I can spend. I know this is a 5:02 now. I mean, it is 2 minutes.